Notice last time I did the integration for a simple beam, yes or no? Yes. And then I mentioned in this class, I mentioned that we can use double integration or we can go to the W, yes or no? Yes. Because for the other class, I remember that for that reason, I'm going to now use here an example which covers both of them. So let's say that we have this problem. Here is a beam which has a load like that. Notice the load this time is not a constant. Therefore, it is a linear. Now, still, both methods work. Two methods I showed you so far. One is double integration. Is that correct or not? Double integration, just let's summarize that. Double integration was when we write EI d2y, d2y over dx squared equal to m as a function of x. This is review. So when we did that, we have two integration. One gives me theta, the other one gives me y. Yes or no? Slope and the deflection. We call this double integration because the starting point is, as you see, at m as a function of x. So you need two integration only, which we have done it in the previous example. Yes or no? Now, the second method, instead of starting here, we can start from load as a function of x. Actually, purposely, I give one of the homework. Your load is a parabola. Yes or no? If your load is a parabola, you cannot find the m as a function of x that easy. You have to use integration under a parabola, which is difficult. Is that correct or not? So we go through the system doing this. I took two derivatives here, and we end up, this is the starting point. For the direct method, I ask you to write it down. I don't know whether you know. This is called direct method, or I call it direct method. In the book, probably, I don't know what they call it, but anyhow, I call it direct method because I'm starting from W. Is that correct or not? So that one becomes EI d4y over dx4 equal to W as a function of x. Now, the first integral become what? The first integral was the integral of W, you know, from 218. The first integral become shear function, yes or no? The second integral become moment. The third integral become theta, and the fourth integral becomes the same format, because when I have the moment and I integrate it, it become like that. Is that correct or not? After two integration, we are back to there. Is that correct or not? Let's write it down here. EI, this is what you wrote last time, dx3 over the integral of that one, because integral of wx over x, everybody knows that's the shear. Is that correct or not? Plus C1, yes or no, which is shear function, yes or no, right? And the next one is EI. What do we get? d2y over dx squared equal to double integration of wx dx, or integral of shear is plus c1x plus c2. That is the equation of moment, correct? Now, where are we? This is the same as this one, is that, except it has c1 and c2. However, this is the equation of the shear. This is the equation of the moment. Some of you actually try to use this to plot your shear and moment diagram. Remember, some of you did, especially Mr. Nazarian, yes or no? Rest, you insisted that's the way I learned it. I said, wait until I show you where is the proper use of those equations. These are the proper use of those equations. Is that correct or not? Yes? Therefore, yes, you can do that. You can integral the W because the area, remember area method, you were actually integrating without realizing. Yes or no? When you were using area method, as a matter, area under the curve, it was shear. Is that correct or not? Yes? So on and so forth. But let me do it. You will see the difference between the two. I'm going for this one is a borderline. This one, I can use double integration method, or I can use direct method. But if it was a parabola, definitely I would use the direct method. Everybody understand that? Yes? Okay, let's see which one happened first. Let's put some number there. Let's say this is equal to this WO equal to 3 kilonewton per meter. let's say this is equal to 6 meters, and I want you to calculate, for example, theta at B and y at B. I give the choice to you either to use double integration method or the direct method. Let's do both of them. Yes? To see the difference between them. Let's use the standard one. The standard one, forget about that one. For time being, as if this doesn't exist, let's go to this. Yes or no? Put that in a box and we'll start from there. Yes? What port B is at the end. So I haven't put it done yet. A and, of course, at A there is no deflection, I'm sorry. At point A there is no deflection. So I do not, that deflection is 0. That's very easy to answer. Correct or not? Yes? You were hoping that would be the question. That would be a very easy question to answer. Yes or no? Yes, of course, it's not, that's not the one. At the end of, because this beam is going to bend. Here, this is a fixed support. Everybody appreciate that that beam is going to bend like that. Is that correct or not? So you have here YB and theta B, yes or no? And in between the same thing, but that seems to be the maximum, yes or no? And usually we are looking for the maximum, correct? All right, now double integration. In double integration, you have to be careful here. Now, I have given this problem before. You have a couple of problems like that, which start like a triangle, or problem number 9 or 10, I don't know, remember that. But students generally have a problem with the static. It should not be there. First of all, like every other problem, the first thing we do, we have to find a reaction, yes or no? So you remove the support, you replace them with appropriate reaction. How much reaction do we have there? Come on, guys, be quick, so we cannot wait here. How was the reaction here at point A? 6 times 3, 18 divided by 2, so there, because this is triangle, is that correct? So it is 9, yes or no? So I have here RA equal to 9 kilonewton, correct or not? Then there is a moment like that, action, and therefore I have a reaction like that. We call it MA because this is a fixed support, yes or no, correct? What's MA equal to? You should be quick in that because this is very simple static. MA equal to how much? 9 times what? 9 times?
3.
4, not 3. 9 because it's 2/3 and 1/3. That's a triangle. You put the load, sorry guys, you know that. You put the load at 2/3 and you don't put it at the middle. You put the load at 2/3 and you put it at the centroid of a triangle. Yes or no? That you're supposed to know. So that distance is how much? 4, correct? 2/3 of 6 is 4. So therefore 9 times 6 is 36. So this MA becomes equal to 36 kilonewton meter in that direction. This is the static of the problem. Yes or no? Which is the determinate problem. Notice we haven't got even into determinate, so you cannot be surprised about it. As I can see it in some of your face, this is absolutely simple case of a static. Everybody should do. No, is that correct or not? So if you made a mistake of 3 instead of 4 at that, you should immediately get rid of it. Is that correct or not? You understood the mistake. Is that correct or not? Yeah? Now writing the M. Now what should I do? I should cut it here, yes or no? And call this distance equal to x. So that is what we are going to do. Before we do that, what's the equation of that line? What's the equation of that line? First of all, that's load, it's not y. Actually, I call this one x and y because of the deformation. But when it comes to x and load, this is load. Is that correct? These are different. This is x, correct. When I function of the load, I have to call this w. Is that correct or not? What's the w? W equal to 3x? 1/2 of x. These are the things that I'm a little bit surprised you guys are not answering me correctly. It's obvious. I'm sure you know it. So please pay a little bit, again, attention. Just you are not paying attention to the detail. Now, let's forget about if this is y, this would be x. Is that correct or not? What's the equation of this line? Everybody knows that. Y equal to what? mx. Is that correct? Or kx or mx? What is m? Slope. See, everybody answer me automatically. But when we come to applying it, everybody looks at it. Notice because that one, you register it by habit. That's a habit. But you didn't understand it. You say, okay, this, that. Apply it. Yes or no? So when I ask you, what's that line, everybody stop there. I don't understand that. This is exactly what I want to change in this class and every class. I want you to think about everything you do. And you do that, believe me, it becomes 10 times simpler. I've told you right now a few minutes ago, I gave you 4 shaft problem or 5. Every one of them had different format. All of them were under one scenario. And if that scenario is missing in your quiz, probably is missing in all 4 of them. So why not doing one of them correctly and spend more time on that? Is that correct? The rest is just, you can look at it and say, oh, I can do that, the rest of it. Is that correct or not? Anyhow, so what I'm saying that, yes, that's the slope. The slope of this line is 3 over 6. So that becomes equal to 1/2 of x. Is that correct or not? Yes? But nevertheless, so here we got it. Again, we cannot go into that much detail. You already know that. I'm sure all of you know that. It's a simple case. Now, when I draw my free body diagram like this, which is now like that. Now, this distance is not L. This distance is x. Now, I have here 9 kilonewton. I have here 36 kilonewton meter. Yes or no? Is this your free body diagram? And then you put here, let's put it in different color. So you put here internal. Now we are in the body. So this is your load. And here is your shear as a function of x. And this is m as a function of x. Because this distance from here to here is x. Is that correct? No. What is the change limit of x? X changes between 0 to 6. Because I can only use one function for entire beam. Yes or no? Correct? Now, what is mx equal to? That's all I'm asking. Forget about shear. You can write the shear. It's time consuming. Let's go right to m. Equation of equilibrium. Yes or no? Sigma what? M about this section equal to 0. That's what we are doing all along. Xx or at xx equal to 0. Now look what we have. 9 times x. Going that way, it is negative. Yes, this is a static, guys. In a static, everything here is positive. Everything here is negative. When you write sigma Fy, sigma m, you are using a static. When you are drawing shear and moment diagram, you are using deformation idea. Everybody understand that. That's the difference between the two. This, everything going, forget about it. This was written based on your shear and moment diagram. But when you look at it, this force is positive, this force is negative. This moment is positive, that moment is positive, etc., etc. Anyhow, those are the things I'm sure you already know. So 9 times x, and that is negative. Yes or no? Then plus what? Plus 36. Then plus what? Well, how much load do I have? Now, here is the problem. How much load do I have here? Faster. How much load is that? Now, this is x. The first thing you want to determine what's this height. Is this height equal to 3 or less? How much less? Is it will be dependent on x? Yes or no? So what is that then? I already written it down there. But that is x over 2. Yes or no? See, everybody's quiet. I know where the problem is. It's just the math. Is that correct or not? When x equal to 1, this is 1 over 2. Everybody, when x equal to 6, 6 divided by 2, you become equal to 3. When x equal to 0, it's 0. Yes or no? Correct? But whatever x is, this must be, that's the equation of it. The y must be equal to x over 2. Yes or no? Yes? Yes. Very simple fact. But then, as I said, now, how much load do I have here? This length multiplied by that length divided by 2, which is what? X squared divided by 2 divided by 2 become x squared divided by 4. Very good. X squared divided by 4. What is this distance? One more time. That distance is what? X over 3, or 1/3 of x. Very good. So that we got it right. Anyhow, so then I have to take the moment. See, I took the moment of that one. This is already a moment. Now I'm working on that one. Plus, because it's going that way, is plus x squared over 4 multiplied by x over 3, which is that moment, plus mx equal to 0. So finally, I got my mx. This is the whole idea. EI d2y. Now you want to write it under that. I didn't have to do that. I could do it in my head, but then for the first time, second time, this is what I suggested last time. For the first time, second time, third time, you draw this free body diagram. After that, you should be better on that. All you have to do, go with action and reaction. The action of this one is negative. The reaction is, look, if this goes to the other side, look, mx. What's mx? Mx equal to, everything goes to the other side, yes or no? Or change sign. So it becomes 9x minus 36 minus x3 over 12. Yes or no? Correct? All right. Now, here, this is the m. So that's the mx. This is the free body diagram. I don't need this free body diagram. I'm going to erase it because I need the board. I am going to do now, here it is. This part of it, from now on, it should be automatic. All the action to you see, reverse it, that's the reaction. Is that correct or not? Again, let me finish this one. This goes to this, 9x negative, I need positive. This one is going positive, I need negative. This load is going to go positive, I need negative. Everybody, because that's the nature of action and reaction. Is that correct or not? Nevertheless, this ends up, let me write it down, 9x minus 36 minus x3 divided 2 times 6. Because I remember I said keep that in the factorial format. So I took that 2 out. So I take those 2 and bring it here.
That was my question.
That was your question. Yeah. Good. Now always we keep it in that factorial in order, because that 2 is extra. That 2 changes from problem to problem. Everybody understands. If I give you this, for example, 2 over 6, this would have been 1/3. Yes, so I'm keeping that out of the formula. This, you want to keep it always in this format, not to make it any difficult. That's what you were referring. Is that correct or not? Yes? That is part of parameter of this format. Is that correct or not? Nevertheless, I think this is the better way. So this is now starting, this method is starting this one with a double integration, because I end up with the m as a function of x. Yes or no? Correct? Now, what was the next thing we have to do? We have now to integrate that twice. Yes or no? Let's do it. So EI dy by dx, which is the theta, we call it dy by dx was the theta, become equal to 9x squared over 2 minus 36 minus x4. This 2 stays there, divided by 24, again factorial, plus constant of C1. These are routine. This part of it, as I said the last time, is very routine. That EI y, which is the next integration. We are doubling. This is what we call double integration. First integral, the second integral. Yes or no? And that become equal to 9 x3 divided by 6 minus 36 x squared over 2 minus 1/2, let's put it that aside, x5 divided by 120, x5 divided by factorial 5, plus c1x plus c2. Notice in this process, we end up with 2 constant of integration because we're only doing two integral. Yes or no? Now, what's the value of c1 and c2? Everybody should see it from the boundary cut. What do we have? Actually, this is much simpler than the previous problem. Which one? This one?
Yeah, because you have the 1/2 on the outside.
No, this is 2 and 24. 24 times 5 become 120. Actually become 240, not 6. It's correct. Yes? 24x5 become 24 times 5 is 120, correct? But we have 1/2 in front of it. Yes, it's correct. But sometimes I make mistake. I want to be sure. Is that correct or not? Yes? All right. Now, how do you calculate C1 and C2? Come on, guys. We did it last time. How do you calculate C1? By boundary condition. This boundary condition is very simple. Look, you know what the boundary condition is, guys? You don't have to go any further. See, it's very routine. I want to tell you, it is very routine. You know these 2 blue lines? Those 2 blue lines, what is that? I told you in the static class. You have a reaction when you prevent a motion. Do you remember that statement? That preventing a motion is a boundary condition, yes or no? RA is there because what? Because the beam is not going up and down. So you don't have to go any further. At x equal to this gives you at x equal to 0, y at a equal to 0, yes or no? Because you have a reaction. If this reaction was not there, the beam would have gone up and this would not be beam at all. Is that correct or not? Yes? Correct? Therefore, if I use that, look what happened. 0, 0, 0, 0, C2 become equal to 0. This is very simple case, guys. Anytime you have a fixed support at the beginning, actually it is to your advantage. Because you have two boundary condition here at x equal to 0. You don't want to your boundary condition at the end. Everybody, that's more mathematically more complex. Everybody appreciate that. Yes or no? So if there is, I have seen a student turn this around because they are afraid of their moment diagram. Remember, as moment equation. You write the moment equation, but here this becomes very simpler. Is that correct or not? Look, at x equal to 0, y equal to 0, 0, 0, 0, 0, 0. C2 must be equal to 0. At x equal to 0, also theta at A must be equal to 0. Why? Because this was a fixed support. This was like that. This is a fixed support. Yes or no? Look at that. There is no rotation there because you have a M there. Yes? Actually, having an M there, that means it has no rotation at that because this M prevents this from rotation. If M was not there, this becomes a P. Is that correct or not? Everybody knows that. So at x equal to 0, theta equal to 0, as you see here again, 0, 0, 0, 0, C1 must be equal to 0. So this is gone, so this is the equation of theta, that's the equation of problem solved. Everybody understand that? Yes? Correct? All right. Now, so let me finish the problem. Theta here become at x, the theta, when you want to calculate theta b, that's what you wanted. Theta b, you have to put in this equation, x equal to what? X equal to 6 meters. Is that correct or not? If I'm putting x equal to 3 meters, I'm calculating everything at the middle of the beam. But usually we are not interested that the maximum is here. Is that correct? Maximum is near at the end, actually. So that problem ends up, you want to write it down. Actually, theta b become equal to. Now, some of your homework are in this format. This is W. This is L, no number is given. Is that correct? The advantage of that, when you do that, you are solving it for 1,000 problems. Then at the end, you can put any W you want and any L. Everybody understand that. Right now, I only solve it for 3 and 6. So if you put a W here and you put a L here, all of this will be in terms of W and L. That's what somebody was asked. That's what you were asking. Is that correct or not? You solve it in that format. Theta b ends up to be equal to, please write it down. Theta b ends up to be equal to minus 1/8 times WO L to the power of 3 divided by EI if you do it with general format. If you do it with the number, of course, the W become equal to 3, L become equal to what? L become equal to 6, which you have to put it here. Everybody under. This is without general. This is I did that in 2 ways in my note. I did it with general format and I did it with the number. I did it for you in the number because it's easier to understand. Yes or no? So that become, when I plug in the number, that number become minus 81 divided by EI. Now, if I give you EI, you can go through the finishing the problem. But many times we solve it in terms of EI, then we can change the beam as well. Is that correct or not? Yes? Remember last time I plugged in EI and gave you the answer, how do we convert our system? Yes or no? Yes. Multiplying by 12 to the power of 2, etc. Anyhow, at x equal to 6, write it down. At x equal to 6 meters, then YB also become equal to. If I put all the number here, you can do it again in general form. If you do it in general form, which is a little bit lengthier, it becomes minus 11 divided by 120 WOL to the power of 4 divided by EI. Or for our problem, we have to do, put here x equal to 6, and you get it minus 356.4 divided by EI. Of course, there is a unit of kilonewton meter square there. So this is kilonewton meter square. Now, whatever you use that, you have to adjust it at the end. If this is Newton meter square, all you have to do, multiply that by 10 to the power of 3 because you don't have any foot-inch conversion. Everybody understand it? Yes, this is simple. Yes? Everybody understand what I'm talking about? Remember last time what I said? At the end, you convert all the foot into the inches, not at the beginning. Yes? So therefore, yes. Yes?
Just want to make sure those two equations, are those general equations for any of them?
No, it's for this beam.
So the 1/8 W not L?
No, that is only happening for this beam.
Okay.
For W in terms of W and L. Remember, if I do that, this become not 9. That become WL divided by 2. And then this become another 10. Everything has to be written in form of that. But that's for this type, for a triangle beam. Yes, for all the triangle beam.
Oh, okay.
Not for any other load. Yes. Correct? But if I come with that number, then I don't. That's why all these solutions are there available. You can look it up. Is that correct or not? Yes. But however, you have to learn it to see the benefit of it. You will see it at the end of today's lecture. Anyhow, that's done. Now, this was the integration method. Yes or no? Double integration method. Let's go to direct method. I'm going to save this here. I want you to see what I did here. I used double integration method exactly like I did last time. Yes or no? Correct? Let's use the same method. This time use it, the same problem. This time use this is 9 kilonewton. So let's put that one here. The 9 kilonewton is there. This is 9 kilonewton. This is 36 kilonewton meter. I do it the way I did it for the first time. All right, now let's start with that one. EI d4y over dx squared equal to W as a function of x. We already expressed that. What's the W as a function of x? It is x over 2, except with one difference. You have to put here x over 2, but notice, if x is positive, W become positive, yes or no? Our W is going downward, so you should put here a minus there. So be careful about that minus. Everybody see what I'm talking about. When you write a function like that, doesn't matter whether y versus x or w versus x. When you write it like that, for x positive, y is positive. Our w is going down, not up. Therefore, it is negative. Is that correct or not? That's why I put a minus there. Is that correct or not? Yes?
No, back over there, versus EI d squared y over dx plus 4. That would be d squared over 2, or is it 4 over 4?
This one or that one?
No, under the 9 kilonewtons, RA equals 9 kilonewtons.
This one? This one? This one? This is 4 over 4, 3 over 2, 2 over 2. Yeah, of course. All right, that's the double integration. Yes, of course. You cannot be d2 over dx. That doesn't exist, such a thing. Correct? Yes? Good. All right. Now, what do I do? This is it. Is that correct or not? But now, look, I need to do 4 integration. Everybody see what I'm talking about. Now, this is the W function. So what's the unit here? The unit here is kilo. Yeah. The next one will be shear. You see, there is totally different. Everybody understand? Now, let's do the integration. EI. Come on, guys. We have to go a little bit faster. d3y by dx3 equal to minus x. Let's put 1/2 in front because I don't want. X squared over 2 plus C1. Yes or no? Correct? Then EI, which is right in front of it, which is shear function. So the unit is kilonewton. No, this is not. The other one is a kilonewton, or this is W. I'm sorry. This is kilonewton per meter. There's something wrong. That is kilonewton per meter. This become multiplied by meter, so it become kilonewton because this shear. Shear is in kilonewton. Yes or no? Mm-hmm. Correct? And then EI d2y over dx squared is equal to minus 1/2 of x3 over 6 plus c1x plus c2, which is what? M function, yes or no? The unit will be what? Kilonewton meter. So kilonewton meter. So this actually takes us back to here, yes or no? Yes? Yeah. If I evaluate C1 and C2, I should get the same thing, yes or no? Okay? Can I use the C1 and C2 here before I go any further? Because I want to show that both methods is the same. Is that correct or not? So here I had 2 options. I could have started like that. I could have like that because I could write M as a function of x is that. If I cannot write m as a function of x, so I go this method. Is that correct or not? Here is automatically. This is my shear function. This is my moment function. What's the value of C1? Look, do you have any boundary condition as far as the shear is concerned? Mr. Nazarian knows that. What is the shear? What's the here? Because he was using this for plotting shear and moment diagram. He must know that. At x equal to 0, what's the value of the shear? 9. Plus or minus? Plus, because it's going down. Plus, that's plus. Is that correct or not? Look, the shear, that's how you are plotting it. Yes or no? Please write it down. These are your boundary conditions. Now, here, this is shear function. I can use any shear that I know that. First of all, I can use at x equal to 8. Shear was 8 or 6. 6. At x equal to 6, this was 3. Shear equal to 0. Everybody understand what happened? Everything. So this is simpler. At x equal to 0, shear at point A must be equal to 9 kilonewton. So I use it here. Look, 9 equal to 9 kilonewton equal to 0 plus C1. Yes or no? Therefore, value of C1 is how much? Value of C1 actually is RA. Is that correct or not? Yes? Mm-hmm. Right. Now, this is simple. Now, at x equal to 0, what is MA equal to? Positive or negative? He is saying negative. Many people saying positive. Which one is correct? Positive or negative? Negative. If Mr. Nazarian was doing it correctly, so it must be right. Is that correct? Is that another thing? Yes or no? Correct. It is negative. Now, you have to be very careful. Yes or no? Correct? You are not looking at this. You are looking at this. Is that correct? This is the action. This is the reaction of the beam, which is here. Everybody understand that? And that system, as you see, push it down, tension on top, compression on the bottom. Be careful here. Exactly the same sign that some of you missed when you were drawing the shear and moment diagram is going to haunt you here. If you didn't learn it there, you have a problem here. So you have to be very careful with this sign business. Is that correct or not? Of course it is. You were a pair. This is the action. This is the reaction of the beam, and that's what we are talking about. ME218 is all about that. So it is not plus 36. It is minus 36, the way you were plotting it, kilonewton meter. So the value, you put it here, again, 0 equal to minus 32. As you see, C2 become equal to minus 36. Now if I put here minus 36, and I put here 9, is that the same equation? It must be. Look at the other one. Is that the same thing? Must be, right? So I don't have to go through this again. But I went through this system. Look, I got my shear function. This is equal to 9. And this is my moment function by integration. Yes or no? Yes? The rest is the same, of course. Everybody see what I'm talking about, right? Look, that ends up exactly like that. Is that correct or not? Look at it. 9x minus 36 minus x3 divided by 12. Yes or no? x3 divided by 12, 9x minus 3. Yes? Okay, this is done. Everybody got it? I can see that some of you are a little bit unhappy about it. Why? Sign convention? You must know. Yes?
Just curious, so when you go 9 equals 0 plus C, where does the EI go? Is it just you know that that's the shear formula?
No, EI, because this part of it is the shear. No, this part, this is the shear function, this is the moment. Is it on the right? Look at that. Yeah. You don't care about it. This whole thing equal to mx. Is that correct? Okay. So the right-hand side is equal to shear function. Is that correct or not?
So you
yes?
know it's equal to shear, so you drop out the other side?
No. No, it is there, but they are equal. They are the same. If you're going through this whole format, this has to have the same unit. This ends up to be equal to that, yes. But EI and the other one, because you saw the unit the way you used it, and that's it. Correct. Is that correct or not? Yes? Now let's do another problem, which is this one you have to be very careful now. So be careful about this problem, and because we are a little bit behind and we have to catch up, because all of this will be due on Tuesday, and we are going to have a quiz on Tuesday as well. So let's now move on to this problem quickly, and you have to be a little bit careful for this problem and tell me what's the difference between the two problems. Here it is. Now, a beam and we have a load here. This is the same beam as I did it before. Remember, the length of the beam was 10 feet. Now here is the same thing, except this is 5 feet and 5 feet there. And then we have here 4 kilonewton per meter. And this is point A, this is point B. And let's say at this point is point C. Yes. Oh, no, I should not. 5 meter and 5 meter. Yes? It's the same problem. Remember, the first problem I did for you was the 10-meter long beam. The load was across from beginning to the end. Everybody see that. Now, what's the difference? Look, go back to your note. See what's the difference between this problem and the other problem. Obviously, the load was all the way to the end. The reaction were equal. Every here, the reaction is not equal. Is that correct or not? Yes, because half of the beam is loaded. Therefore, the total load there was 40. Here, total load is 20 being applied there at the middle. Yes or no? Then you find the reaction. I leave that part to you. So the reaction becomes 1/3 and 1/4 here, 3/4 there. So this one becomes equal to 15 kilonewton, the ratio. And this one becomes 5 kilonewton. This is the reaction. This system is determinate, so you can solve the static of that and get that. Is that correct or not? Yep. Right. Now, can I use the same technique? Can I use either this method? First of all, it's not required to use direct method because M is much simpler to write in that format. What is the difference between this problem and the earlier 2 problems that I did? What? That's right. Notice, you know that from ME218. Now, notice the function that really I have to come up with mx. Yes or no? Can I write the same mx for AC and CB, or they are different? Actually, you know, everybody knows that. At the moment here is linear. Yes or no? No load, shear is constant, moment is linear. Constant load, shear is linear, moment is a parabola. Totally different function. It cannot be represented with one set. Write it down. This type of problem has to be represented with 2 set of functions. Therefore, we have 2 set of integration which are totally different. This line, like a metro, this is a red line, this is a blue line. And if you want to sitting in the red line, when you get to that station, you have to get off and get into the blue line. Because if you go with the red line, you go somewhere else. Is that correct or not? Everybody see what I'm talking about? Yes? Exactly like that. There are 2 different deformations. The beam comes together. So that's why I'm going to use color code like this. So what I'm telling you is this. If I'm using this part as a beam like that, this beam bends like that up to this point. Yes or no? And then suddenly the whole thing changes because M is changing. If M is changing, all this function changes. Is that correct or not? Therefore, it may even go further down. I don't know how far that goes. Maybe the maximum is here. Then it goes like that. So we have a purple line and we have a blue line. So let's establish exactly like that here what we do. Now, my method is just a little bit different from the book, and I want you to follow this rule exactly. One of the rules I already gave you last time, which you follow it here, is xn divided by factorial n. The second one, you will see it in a minute. You write x between what? 0 to 5, which is the purple line. Is that correct or not? For color, just for you to remember it. Otherwise, it's not necessary. Is that correct or not? Then x between what? X between 5, because you are going to use, this is another thing. In the book, sometimes they change that from this point to the other point to the other. I do not recommend it at all. If you stick to the same x and y, at the beginning, your math is a little bit difficult, but at the end, your math becomes 1/2, 1/3. So please listen to me carefully. Use the same x and y. Everybody understand what I'm saying? Do not change it, even if you see it in the solution manual. If this x is between 5 meters to what? To 10 meters, which are under the blue line. Is that correct or not? Now let's write EI. I'm using double integration. For this one, double integration is good. So I'm using the double integration method. EI d2y over dx squared equal to, now I am hoping that you don't need a free body diagram. What is m equal to? What's m equal to? For this, for that. 5x, is that correct or not? Positive or negative? Because action is negative, reaction is positive. You have seen it 100 times. I use it, not 100 times, 2-3 times. Is that correct? Or you see it happen everywhere. Is that correct or not? Yes, so it is RA, look, RA times X. RAX. Is that correct or not? Yes? It was in previous problem. By the way, if you do that 1 or 2 times, you would avoid this. That's what I'm asking you. The only way to get into this habit without going too many free body diagram, too much time, like your shaft. If you would do your shaft correctly, then you know how to get rid of your beam quickly. Everybody understands. Otherwise, it's not the first time you are doing it during the quiz time. Is that correct or not? That's why it takes longer. Look, it is a routine. The action is 5 times x, yes or no? It's going this way, I want that way, yes or no? So it is 5 times x, as simple as that. That's it. This is the moment here, correct? There is nothing else, because as to go up further, it still is 5x. It's very simple, yes? Right? Because the other one had load, this one doesn't. Then let's go to the integration. EI dy by dx. Now, since this is the purple line, I'm going to give it a subscript of 1, because these are y1 and these are y2. So to make it separation between the two. Equal to, here I have to put a y1 here. This is representing, this is y1, and that is y2. Everybody understands, as a function of x. So therefore, it becomes equal to 5x squared over 2 plus c1. And then EI, in other words, this is, let's put it this way. This one becomes EI theta 1, which is the purple one. We have a theta, we have a y. We have a theta, we have a y. This is the equation of theta, become equal to 5x squared over 2 plus c1. And EI y1, which is this curve, from 0 to 5, for everywhere. From here to this x applied to 0 to 5, not further. Become EI, oops, sorry, we don't have that. Then become 5x3 over 6 plus c1x plus c2. Correct? Now let's go here. EI d2y over dx squared equal to 1. Now this one, since this is the first time, and I noticed previously some of you, not all of you, a few of you had problem with writing this as a function of the x. Let me do it with a free body diagram one more time. Is that correct or not? But then again, you should be able to do it with your, sort of by looking at it. This is the system. This time, notice the first time I cut here and call this distance equal to x. So the answer was 5x. Is that correct or not? 5 times x, correct? Now I have to cut it here, yes or no? But I'm going to call this distance equal to, now some of you in AB 218, you call this distance x, because you think the starting point here. No, x start from point A, yes or no? Because you are not changing your coordinate, yes or no? Still this point is x5, this point is x10. If you put your new x coordinate here, this has become x0, this become x5, which has nothing to do with the other coordinate. They have some relationship, but you cannot do that because I asked you to use the same x and y coordinate, yes or no? So with the same x and y coordinate, the distance from here to here is x. Is that understood? And you cut it here, so this will be your free body diagram. You have 5 kilonewton here. You have cut a little bit of the beam, not much, because you are right now where? This is the 5 meter. Is that correct? This is point C, so this is 5 meter. But this distance from here to here is x, correct? Right? And you are calculating, I'm doing here, I'm putting here the blue. This is shear as a function of x and m for the blue region. This one actually was, this was purple one. This is the purple area. This is the blue area. Is that correct or not? Yes? What is m equal to? Right, it's static. Yes or no? Sigma m at x equal to 0, or this line. 5 times x, negative, yes or no? Plus this load. Now, how is this load? What's the magnitude of that load? Be careful what you are saying there. 4 times what?
X minus 5.
X minus?
5.
Very good. See, it's sitting in front of you. If this is x and this is 5, this length is a variable. It's x minus constant of 5, yes or no? So this is load is 4, that's the W, times x minus 5, okay? So that's the load. Times what distance? The distance is minus 5 divided by 2. Actually, if you look at it, it's very routine and very simple. So minus 5x, this is the static part of it, minus 5x plus 4 times x minus 5 times x minus 5 divided by 2. So it becomes like that. Is that correct or not? So it becomes the same format, except instead of being x squared over 2, become x minus 5. This is the same format, except x become x minus 5. Is that correct or not? Yes? Divided by 2 plus what? Plus mx, because this is plus, equal to 0, or mx equal to 5x minus, 4x minus 5 to the power of 2 over 2. Now, I'm going to put that one here. 5x minus 4 times x minus 5. Now, my request from you, if you want to follow my format, which is many people use it always as well because this is the computer format, never expand this. Some of you are noticing ME218, try to expand it as if to mix it together. Then you say x squared plus 25. Never do that. Write it down. Never expand it. Keep it in this format. It's much, much simpler to do that. Otherwise, you get into lots of trouble in math. And again, use it in the factorial format. Notice I do not divide this 4 by 2. Everybody remember, this 4 was W, that 5 is a reaction, etc., etc. I keep it in the same format as before. Is that correct or not? So this is the moment for the second part. Then I go ahead and do the integration. Okay, so look what happened. If I do the integration, so EI, this time become theta 2, because theta 2 is this part of this. Theta of this, these are the theta for this line, equal to 5x squared over 2 minus 4x minus 5 to the power of 3 over 6, plus I cannot use C1 and C2 because I already use C1 and C2. I have to use C3 and C4. Is that correct? That is the equation of the theta for the blue portion. Yes or no? Then I have to write equation of the y, y2 equal to 5x3 over 6 minus 4x minus 5 to the power of 4 over 24 plus C3x plus C4. Suddenly, instead of 2 constant of integration, how many do I have? 2 and 2, because I'm doing it twice. Is that correct or not? So how many boundary conditions do I need? 4. Otherwise, I cannot solve. What are my boundary conditions? Again, look at your reaction. What is this? What does this tell you? At x equal to 0, y equal to 0. So let's write it down. Here, for this portion. You see, these are 2 portions. Don't mix these 2 together. Some people do. Some people use this for the other one. If you do that, that's a no-no. Look, this is x only between 0 to 5. That is x between 5 to 10. It's 2 different regions. Is that correct or not? Yes? So at x equal to 0, this is what I put here, y1 and y2. y1 is equal to 0. It has nothing to do with the blue line. Is that correct or not? Yes? So apply to this one only. So y1 equal to 0. This is 0. This is 0. As like before, C2 must be equal to 0. C2 become equal to 0. Then what's the next one that you see right away? The one that you see right away, like before, is this one. Yes or no? At x equal to what? 10. Which y is equal? Is it blue one or the purple one? Obviously, it is blue one. Applies to this set, yes, not to the other set. So that I write it here for time being. I'm not using it, not yet. At x equal to 10, y2 equal to 0. Yes or no? But I need 2 more. Where are the other 2 more?
At 5.
Good.
X equals 5?
That's right. Notice, although this is two different functions, like your road when it goes into the curve. I don't know whether some of you are civil engineers, you are not civil engineers, so you don't know that. So when you go to the curve, the civil engineer, when they design that, you have a parabola here, a parabola. When they come together, they cannot go like that. If they want to go like that, they have to make it an intersection. Everybody understand that, yes? It is tangent to each other because you don't want you to feel it in your car. It's actually that's a very large curve. Is that correct? Or they make it looks like that you don't feel that. You turn your car a little bit, but it goes smooth. Is that correct here? This is the same thing. The beam, if it's like that, is already broken. Yes or no? The beam goes through the deformation, but at that point, look at that point, look, they are tangent to each other. Look at the way they do. So at this point, theta is the same because they are tangent to each other. Is that correct? It's not like that. Everybody see what I'm talking about. Please write it down. This we call it compatibility or connection point. Here you put it at the middle. So here you write at x equal to 5. Peter, absolutely right. You write theta 1 must be equal to only at this point, not at any other point. You see, theta here is not equal to theta. At this point, theta 1 must be equal to theta as the border. That's why we call it boundary condition. At x equal to 5, obviously y1 must be equal to y2. So how many boundary conditions do I have? 1, 2, 3, and 4. Yes or no? So for your 4 constant of integration. So the solution is like that. So let's use the solution now. At x equal to 5, theta 1 must be equal to theta 2. Yes?
Y1 equals Y2, right?
What? Yeah. Y1 equal to, as theta at x equal to 5. No, don't put, some of you put this equation equal to that equation. That's wrong. When you plug in x equal to 5 and 5, these two become the same. Is that correct or not? So the result is this. I put it in front of them. So in the first one, for that you get 5 times 5 to the power of 2 divided by 2 plus C1 equal to this one. You get what? This is the theta 2. Yes or no? So you get 5 times 5 to the power of 2 over 2. Now, this is the beauty of I said I do not expand. When you expand this, you lose this one. Here at x equal to the 5, the whole thing become equal to 0. Everybody understand that? Never, ever, write it down. Never, ever expand this. If you are expanded, you have to write 3 pages of math. Everybody understand? Because this goes to the power of 3. You have to take the moment of each term. Everybody understand what I'm saying? It never works in that format. It has to be left in this format. Is that correct or not? And the beauty of that is you are going to put x equal to 5. That's the boundary line. Yes or no? The whole thing become equal to 0. 5 minus 5 becomes 0 plus C3. And these are the advantages that we get from writing this in very nice format. Notice this one and this one drops out. Therefore, C1 must be equal to C3. Please write it down. The result of this one, C1 equal to C3. Okay. Now, we use the second one. Can I erase this? Yes or no? Now, the next one is what? At x equal to 5, now y1 equal to y2. Means this quantity equal to that quantity when x become equal to 5. So please write the same thing. I'm going to write it here. This become 5 times 5 to the power of 3 divided by 6 plus C1 times 5, this side, equal to, that's y1, equal to y2. Notice we don't need EI, we need that side. So equal to 5 times 5 to the power of 3 divided by 6 minus what? The whole thing become 0 again, 5 minus 5. Is that correct or not? Yes? When you put x equal to 5, 5 minus 5 becomes 0, so you don't have to worry about it. Never, ever expand it. Plus minus 0 plus C3 times 5 plus C4. Again, this and this drops out. This is the beauty of this method. You have to follow this method, which is sometimes the book, they do not follow this method, so you get a different answer. Look at C1, 5, and C3, 5. But we already established C1 equal to C3. Everybody understand that? Then this 2 drops out. And then C4 become equal to 0. So C4 become equal to 0. So we already read that. The last one that we have to use, we use at x equal to 10, y2 equal to 0. That's the one I have not used. So this is right. I'm going to erase that. I don't need all of this. This is all gone. Now we come to the last part, which is here. At x equal to 10, this quantity must be equal to 0. Yes or no? Y2. But notice C4 was equal to 0. So you write 5 times 10 to the power of 3 divided by 6 minus 4 times 5 to the power of 4 divided by 24 plus C3 times 10 equal to 0. You have one equation for C3. And don't remember, C2 are 0 now with this method. C2 is 0, C4 is 0. If I calculate C3, I already have C3 and C1. Yes or no? Correct? Because they are equal. So you solve for C3, and C3 is become equal to C3 become equal to, if I find it, okay, it is here. The answer for this one, you have to simplify that. C3 become equal to C1 equal to minus 72.92. Of course, they have different unit, but you have to, no, actually they have the same unit, kilonewton meter square, because they are here in Tate. Okay? And the problem solved. Is that correct or not? Now, if somebody asks you what is the deflection here, you have to use this equation, yes or no? If they ask you what is theta A, actually I calculated. If I want to calculate theta A, I have to use this set. Is that I have to put in this equation x equal to 0. Is that correct? Let's do that. Calculate theta A, guys. Calculate theta A. How do I calculate theta A? Of course, theta A belongs to purple line, not belongs to blue line. Is that correct or not? So if somebody asks you what is theta A, the rest is you can answer sure, definitely. You put at x equal to 0, and you calculate y1 at A, which is, theta A, I said. Theta at A, so theta 1 at A, and that is equal to this equation. So x is equal to C1 over EI. So that's what you want to come. You come C1 over EI, and C1 was equal to how much? C1 was equal to minus 72.92. That's right. Minus 72.92 EI, etc., etc. If somebody asks you to calculate what is y at this point, which you will be interested, that is either you can use this one or use that one. The net result should be the same if you have not made any mistake. Is that correct or not? And so on and so forth. Everybody understand that? Now, you have to understand that this problem requires doing it in two steps. Now, if I give you this beam, this is for future. And I give you one load here, one load here, one load here, for let's say one moment here. How many times do I have to do this one? Well, you have seen this beam. Is that correct or not? Yes. How many times do I have to change this set? 1, 2, 3, 4, 5, and 6. Each time I get 2 constant of integration become 12. Is this practical? At x equal to a, theta 1 equal to theta 2, x is equal to 2a, theta 2. This is not practical. This is what we are going to bypass this next time by going through a new system. New system is getting rid of this section. However, for your first set of homework, you have to do that. One warning, though. One of your homeworks looks like this. I said that last time, but probably you didn't grab it. When you have something like that, and this is A, B, C. Have you looked at your homework? Yes or no? Some of you did? No. Now, if there is a question about point C, you have to do it A, B, and B, C. But if there is nothing being asked about point C, you can put that moment here because that moment comes here. You only do A, B. So remember, in a couple of problems at the beginning, you don't need to use this technique because still the question is all about A, B, not BC. Everybody understand that? If it is like that, you have to do it this way. Is that correct or not? So please be careful. Couple of your homework does not require like that. There is another homework which is symmetrical. So if it is, if there is one homework like that, that one you have to do it 2 parts, AB and BC. You know, you draw your shaft, you know what the moment is. The moment looks something like that, yes? this function is different from that function. Everybody understand what I'm saying? That so that one has to be integrated between A to B, and then it integrated between B to C. However, if this load is at the middle, do I need to do it in two parts? No, because it is symmetrical. No, that's symmetrical. And if it is symmetrical, theta at the middle must be equal to 0. So you use that technique, only do half of it. So please be careful. All of those math part is part of this. You have to be good at math to understand all of that. Yes or no? But required also a little practice. Don't do extra work. You do 1 or 2 problems. If there are 10 or 12 problems, do one of each one correctly, and you will be set. Now, the next very, very important part of this, which really everything that we said so far from day first in ME static, in ME 218 and 219, it has one purpose behind it. And that purpose is the next problem. These are all become in future for you guys, become all irrelevant because these are all determinate problems. Yes or no? The problem, the real problem always is indeterminate problem. Indeterminate problem means by a static alone, you cannot find out what the reaction is. I am going to do that, and I'm going to, please write it down. This is the most important. Actually, if you quite frankly ask me, everything that you learned so far was for this problem only. The rest, you can find the solution in every book or every internet. Everybody understands that. Those solutions is for you to learn the subject. The actual use of this material comes when you want to solve a new problem, which 99.9% of the time is going to be indeterminate. Now, what you mean by indeterminate is this. Remember, I did this problem, or this was one of your homework. You have a, not like that. You have a beam here. You have a load like that. Yes or no? Correct? Let's do that problem now together. This is really the bulk of the matter, and this has been a quiz in the past, so let's look at it this way. So we have here the length of 8 meters. The load is 4 kilonewton per meter. And if I give it like this to you, notice what happened there. This side is going to go down, yes or no? I already solved a problem similar to that. It was a triangle load, which was much more difficult, yes or no? But we have here a reaction and MA, yes or no? That system was indeterminate because I have AX, AY, and MA, 3 unknown, 3 equations, yes or no? As soon as I come and put another support here, don't ever try to do this by static. Although I'm saying it in every class, and I have said it in every class in the past, I always find 1 or 2 or 3 students who solve this problem by static and find out RA and RB and M by some magical formula. I don't know what that magic is, but I know that if they do that, they are entitled to Nobel Prize. That's it. I'm always, don't tell anybody, let's share it together. I get a portion of that. Yes? However, what I'm trying to tell you, never ever do that. You know why? Now, how many unknown do you have? Look, you see one more extra unknown, yes or no? You have R, here, let's put here point A, here point B. You have RA, RB, MA, and AX, yes or no? So you have 4, you have 3 equations of equilibrium, granted. Sigma fx equal to 0, AX is 0, 1 equation gone, 1 unknown gone, still 3 equations left, 2 equations also. Sigma fy equal to and sigma m about either A or B. Not quite frankly, if we be serious case, this is what they do. They write RA plus RB equal to 4 times A. That's true. Is that 32? Some people make this drastic mistake. They think this is symmetrical. They put here 4 times A, 32. They put here 16 and 16. Is that correct? No. Absolutely not. That's the whole idea. If you do that, you solve it. Is that correct or not? It's laughable. That's right. Some people do something differently. These are happen occasionally. I'm saying that in order for you guys not to fall into that trap. Is that correct or not? So some of them do this. They take moment about here, then they see they have too many unknown, then they take moment about B, and then they make a mistake, plus or minus, then it becomes independent equation, then somehow they come up with number. They come up here, let's say 18 and 14 there. Everybody understand what I'm saying? That's what I'm talking about. No, it's impossible, yes? So the whole idea from day first to today was to learning all this static strength of material is. Now what happened here? I cannot find RA, I cannot find RB. I cannot draw my shear and moment diagram, correct or not? I cannot design this beam. I have nothing. I only have the knowledge of static and strength of material. Let's see whether it works or not. However, I know from static, that's why you have to know that. I have reaction here, so let's put it this way. So here I have reaction RA and reaction, moment reaction MA. Don't forget, oh, this is another mistake. Some people forget about that. If you forget about that, you are back to determinate problem, yes or no? If you put here RA and RB, so obviously this is 32, this must be 16 and 16. That's another mistake. Some people put MA here, but they forget to put it in their equation. I have seen all sorts of it, but this is the same, this, as if you forgot about it. Is that correct or not? Story short, this is not solvable. Yes, we have to go through this system to solve this one, static of this problem. The question is, what is RA? Write it down. What's RA? What's RB? In order to do that, static is not sufficient. Everybody understand that. It is indeterminate. Let's go through the deformation. That is solving this problem. Now, let's write it down. So cut it here and call this distance equal to x. Let's go a little bit faster. We are running out of time. EI d2y over dx squared equal to moment as a function of x. Remember, RA is not given, MA is not given, RB is not given. Yes or no? But so be it. Still, I can go forward with that. It's in terms of all this unknown, the purple one. Yes or no? What's the moment here? Now, tell me. You don't want the free body time. What's the moment here? RA times positive or negative? First, the action is negative. The reaction is positive. RA times x. Granted, RA is unknown yet. Is that correct or not? Yes? Then what? What's the effect of MA? MA is going positive, I want a negative. So minus MA. If you recall in the other problem, if you match it, the other one we wrote minus 36. Here I don't know the value of that. I have to write minus MA. Is that correct or not? Yes? The other problem was 36. Do you remember? Yes, yeah. the determinate one, right? Okay, then what? It's not finished though. This is 1, this is 2. How about this load? What is that load equal to? 4 times x times x over 2, the action is positive, the reaction is negative. Very good. You see, you should be able to do that. After you do that once or twice in your homework, believe me, every one of you can look at it and write it down. Everybody understand it, yes? Right? If it is too complex, then draw a free body diagram. But you have to get beyond this. That's it. Is that correct or not? Granted, RA is unknown, MA is unknown. Not yet. However, in this corner, I know this. RA plus RB must be equal to how much? 4 times 8 must be equal to 32 kilonewtons. That does not change because that is sigma Fy equal to 0. Yes or no? I have one more equation of a static, and that equation of static is sigma m about a point equal to 0. Either A or B. Notice I leave that for the last. You should always do that at the last. But there are 2 equations. Equation of equilibrium is still there at your disposal. Correct? Now let's go through the system, see what happened there. Then we go here. You see what happened. EI theta equal to RA x squared divided by 2 minus MA as x. You have to put this because this is MA. And minus 4 x3 over 6 plus C1, correct? And then EI y equal to RA. I know some of you surprised why I'm doing that, because I'm adding to my unknown. Notice another unknown was added here. Yes or no? Correct? I already had 3. I have quite a headache. Now I am adding 2 more to it. Is that correct or not? Yes? So RA x3 over 6 minus MA x2 over 2 minus 4x4 over 24 plus C1 plus C1x, I'm sorry, C1x, because you are integrating, plus C2. Now, how many unknown do I have in total? C1, C2, RA, RB, MA, yes or no? So write it down. This formula always exists for this type of problem. The beauty of that is this. It takes care of it by itself without you realizing what's going on. It solves the problem with you in this format. Always this is true. It's not in the book. You want to write it down. The number of constant of integration, number of constant of integration, in this case, how many do we have? 2. Plus number of reaction, unknown reactions. How many do we have? 2 and 3. You see, 1, 2, 3, 4, and 5. Yes or no? Equal to, how many boundary conditions do we have? No. 2. Previously we had 2. Now you have 1 more. That's the beauty of that. You need to realize that. It's very interesting. You have this RB there, put it there. Correct? If this RB was not there, this would be a determinant problem. It would have been no problem. Yes or no? You put an RB there, you made it this, an indeterminate problem. Yes or no? Then at the result, you have 1 more boundary condition, and that should be doing it for you. So it doesn't matter how many more unknown you have, that many more boundary condition you have. This time you have 3, not 2. Look, at x equal to 0, y equal to, at x equal to 0, theta equal to 0, at x equal to L, y equal to 0, that's 3, plus 2 equation of equilibrium, 5 equal to 5. So it doesn't matter. As soon as you put another support here, you get 1 more reaction, 1 more unknown, correct? But you get 1 more boundary, and then this problem is solved. So that is what we're doing all of this for. Everybody understand that? So here we go. Number of constant integration in this problem, 2, plus number of unknown reaction here, 3, equal to number of boundary condition, in this case, plus, of course, equation of equilibrium. Don't forget that. Equation of equilibrium is still part of the deal. We have 2 equations of equilibrium left, yes or no? 3 boundary condition. Let's solve it. Give me a few minutes extra, because without this, you cannot do the last 3 problems. However, be careful what we are doing here. Let's do just give me a couple of minutes, because we have to finish this one. Let's do one by one. Actually, it's very simple. Look at it. First, at x, let's do it here. At x equal to 0, theta equal to 0. Yes or no? See, x equal to 0, 0, 0. C1 must be equal to 0. Actually, it's very good for you to have your support at the beginning, not at the end. I said it earlier. At x equal to 0, theta equal to 0, 0, 0, 0, 0. C1 must be equal to 0. At x equal to 0, y equal to 0. So again, 0, 0, 0, 0, 0. This is already gone. C2 must be equal to, this is C1 equal to 0, C2, but check it. Sometimes this is not true. If you do not have a fixed support here, one of them should be 0. Everybody understand that. The other one you have to calculate, yes? So, but this problem actually is simpler. To put a fixed support here actually is to your advantage. C1 and C2 become equal to 0. Now, what's the last one? This is the one. This is the key to the entire problem for indeterminate problem. At x equal to L, y equal to 0. So what's XL here? This is, I'm going to erase that because I want to use it this board here. At x equal to what was the total? 8 meter. Y, in other words, at B must be equal to 0. So you write this equation. You write RA times 8 to the power of 3 divided by 6 minus MA 8 to the power of 2 divided by 2 minus 4 8 to the power of 4 divided by 24 must be equal to 0 because both C1 and C2 were equal to 0. Is that correct or not? I put here 8. Look, this is, look what happened here. Without you knowing, you establish a new relationship between RA and MA, and that's what you wanted. You have two equations of equilibrium, and this was the third one. Look, happened automatically. Everybody see what I'm talking about? Simplify this one. When you simplify that one, that becomes equal to 8 RA, because some of these 8 drops out. As you see, 2 of them drops out. It's very simple. This was a quiz, by the way. Actually, I'll tell you what happened. Minus 3 MA become equal to 64. This is equation 3. Everybody understand that? Now, between these three, I should be solving this problem. Now, is it better to take moment about A, or is it better to take moment, look at this equation. Is it better to take moment about A, or is it better to take moment about B? B, exactly. Everybody understand why? Because your relationship between RA and MA, it's solvable, but if I look at it, I need another relationship between RA and MA. Therefore, I want to get rid of RB, yes or no? This is not in reverse of a static. So this time we take the moment about point B. So that's this one. Now I decide, that's why I left it out there. Sigma MB equals problem to problem, this changes. You have to decide which one you want. So when you do that, since we are running out of time, I'm going to write, let's write it, because that one, sigma MB, I'm going to write it here. Sigma M at B equal to 0. Notice you have RA times 8 negative plus MA positive plus this 4 times 8 is 32. Is that correct or not? 32 times 4, yes or no? Plus 32 times 4, and that one is plus equal to 0. When you simplify that one, that ends up to be equal to minus 8 RA plus MA equal to minus 128. Notice it is very simple. This was a quiz, so I make it very simple for a student. Notice all you have to do, add these two together, yes or no? When you are adding these two together, RA will be 8 RA and minus 8 RA eliminated. You have minus 2 MA equal to minus 64. Therefore, MA become equal to 32 kilonewton meter. You put MA here, you calculate RA. RA become equal to 20 kilonewton, and RB become equal. For the first time, you guys were able to solve an indeterminate problem with the aid of a static and strength of material. Everybody understand that? Now, this was a quiz, guys, let me finish this problem because I mentioned it for the other class. Just give me 1 more minute. Now, if this happened, which is indeterminate, and the load is halfway through, notice you have to use also 2 span. Everybody understand that? You get 2 more unknown. That changes the problem a little bit. It is, if more than 2 span is not practical, everybody understands it because there are too many unknown. We get rid of that one. However, this was the quiz, so I asked the student to plot the shear and moment diagram. This is what I've done. You got the reaction at RA equal to how much? It was at 20, so you start at 20. Then you drop it by 32. You end up at 12 here. Is that correct? That's your shear diagram. Your moment diagram, I asked them to plot it because it is covered. You start your moment diagram as how much? At MA 32, plus or minus?
Plus.
Minus, okay. And then it goes like that. So at this point is maximum. So here, that's where shear is equal to. Anyhow, so that was it. You are all equipped to do all your homework. Any question? Tuesday is the day you want to ask it. Is that correct?